In our last video, we saw that exist different types of maintenance that we can implement in our installation, different type of task of maintenance. But for the maintenance responsible, what is really important is not the different type of task of maintenance that we can carry out in one installation. The most important thing is how to organize the maintenance and which strategy we can follow to obtain some result in terms of cost, in terms of availability, and even in terms of useful life of our installation. Then in this video we will show the strategies of maintenance. To understand the different strategies of maintenance that we can have, it is important to see the history of the maintenance. And according with this history, we recognize 4 different periods. These different periods has a relation with these strategies of maintenance that we can follow, and for that reason it is important to have a look to this history of maintenance. The first moment in the history of maintenance is the prehistory of the maintenance. It's one moment when the maintenance, the operation and maintenance was not divided. Then the operator that operated the machine was able to maintain the machine, means it was able to repair the machine. In this moment, the machine was very simple. It is possible for the operator of the installation to understand very well the mechanical element of the machine and to solve the little problems that can appear in the mechanism that conform the machinery. Then this first moment was the prehistory of maintenance, and really does not exist maintenance because the operator do itself the repair of the machine. But after this first moment, more or less in the second industrial revolution, the machine in this moment was more complicated. Then was not possible that the operator that operated the machine was able to repair, because the knowledge that he need was different, was a little bit different. Then appear some worker specialized in maintenance to maintain the machine. Then in this moment appear the maintenance department, and these people that belong to this department of maintenance, the things that they do was repair the machine. In this first moment, the maintenance of the machine was based in the reparation of the machine. Then was a corrective maintenance. In this moment, the industrial responsible, the maintenance responsible, was in charge of repair the machine, and this is the only thing that they do. This conform our first strategy of maintenance. Focus pay attention only in repair the machine. Actuate in the machine only when the machine has a failure. But during the Second World War, the responsible of the industrial installation saw that this was a not very good strategy for maintenance, because sometimes the failure, as you know, happened in the worst moment. Then was not possible to know if the machine was in production or was perfectly available in the moment that we need. For example, could happen that we need to send some balls, for example, to the war, and in this moment, exactly in this moment, the machine stopped because it has a problem. Then they start to think that it is necessary to avoid the failure, but even if it's not possible to avoid the problem, at least to know when the machine will be stopped to do some repair or to do some activity to avoid problems. In this moment appear a second strategy of maintenance. This second strategy we can think or we can put one name like preventive strategy, but I prefer to use another name. I prefer to use the name of systematic strategy. In this moment, what is established is that all the elements of the machine has a useful life, and it is important to determine this useful life and replace this element before the end of this period of time. Then in one machine, all the elements has a life, and for example, one bearing has 6,000 hours of operating hours, and then once the machine reach this life, it is necessary to replace bearings or filters or some pieces. And every element of the machine in terms of operating hours or in terms of time intervals was fixed in which period is possible to operate the machine. Many important industries turn to try to implement this strategy, this systematic strategy. And according with this systematic strategy, we establish that every element has a life. And if we want to avoid problems, we need to replace every element of the machine according with some planification. A little modification of this strategy, systematic strategy, is the high availability strategy. And according with this strategy, all the activities from a systematic point of view or from a preventive point of view are grouped in moments, in some moments. And normally, once per year, it is necessary to stop our production and to carry out some activities, some changes, some intervention in the different machines that compose our installation in order to replace all the elements that more or less has finished his time life. It is important in this second modified strategy to group the activities in order to avoid the stop of the installation. For example, if we determine that one bearing, for example, has a useful life of 4,000 hours, and then but there is another element that has a useful life of 5,000 hours, we replace two of them at the same time to avoid downtime. But in the history of the maintenance appear a third moment. Appear that the technician, the maintenance responsible, saw that it's not easy to determine which is the useful life of every component of the installation. And even more, in the 17th, more or less, a couple of technicians, Nolan and Heap, determined that doing some statistical studies that is near impossible to determine the useful life, and even more, some component has no a useful life that you can determine in terms of operating hours or in terms of interval of time. Then they determine that there is some shapes to define the probability of the failure with the time, and near 90% of the element has no a useful life that you can determine. Then this was one proof that it is not easy to determine and to fix in which moment it is necessary to change some element. And appeared a new concept. This concept is called condition-based maintenance. One maintenance based not in the repair of the installation when the installation is broken, no in the useful life of every component of the installation, is based in the condition that present the machine. And then appear the concept of diagnostic. It is necessary to diagnostic the machine, and it is necessary to know which is the condition of every element of the machine, doing some observation, doing some inspection, or doing some test in the machine. Only if the machine has a problem, only if we detect some problem that this is generated or some potential problem, we do something. In this third strategy of maintenance, condition-based maintenance, there is an axioma, more important than the rest, is don't repair what is not broken. That means it's not necessary to open one machine, or it is not necessary to replace one element if there is no any symptom to be in bad condition. And then if all the elements that present the machine has in good condition, it is not necessary to do nothing except to do the necessary inspection to determine if the machine is working properly or not. In this strategy exist different techniques to determine if the machine is working well or not. First, the operator can do some sample test every day or every few hours, etc., to see if the machine, if the behavior of the machine is according what he knows or what he established a standard. Second group of activities is with the instrumentation that is implemented in the machine, the instrumentation that we have online in the machine, we can analyze if the machine is working well or not. We can carry out inspection in the machine, detailed inspection with a checklist to check which is the condition of every part of the installation. Some of this inspection it is possible to do with the machine working, with the machine in operation, and some of them to carry out this activity it is necessary to stop the machine and to check, to dismount some covers or to dismount some element to check these components. And of course, exists another third way to determine if the machine is working well or not, is install some special instrument, install some instrument that you have with you offline, install this instrument and do some observation or some measurement to compare the result of this observation or this measurement with the standard that we know as normal. In case that the observation of the measurement indicates that the machine is not working properly, is not working well, is out of range, then in this moment it is necessary to organize an intervention in the machine to organize the substitution of one element or the change of something, or doing some cleaning or doing some adjustment in the machine. See which is the difference between the three strategies of maintenance. According with one strategy, in one installation, the maintenance responsible says anyone do nothing except if something, some element, some part is broken. Only if we see something that is broke, we do something. Then this strategy is very comfortable for the maintenance responsible, because he doesn't need to think at all. He needs only organize the resources. The most urgent is the most important. Then he receive normally from the operation people. He receive the different communication about problems in the installation, and he organizes according with the resources that he has, how many people he has, how many means he has. He organizes the repair. The maintenance responsible does not need to think, only organize resources. In the second strategy, is more efficient because you obtain better results in terms of availability, but probably in terms of cost. The results are not so good, because remember that you decide to replace an element. Doesn't matter which is the condition of this element. Doesn't matter if, for example, you decide to replace one bearing every 6,000 hours. It doesn't matter if the bearing is in good condition or not. Then, for that reason, the maintenance is more expensive than one maintenance based in the sample repair of the installation, or based in the condition that present the installation. And the third strategy is a strategy based in the condition, based in the diagnostic, in the previous diagnostic of the installation. And which is the situation of the industry? Well, depend of the country, depend of the sector, but more or less an important part of the installation are under a corrective strategy. This corrective strategy is the best in terms of cost, in terms of availability, in terms of useful life? Probably no. Probably this is they are not. It is not possible to obtain the best result following this strategy. But what happened with, for example, the power industry, or with some important industry? They follow one systematic strategy. Sometimes it's because the increment of cost is not important, and is more important the increase of the production, and they follow this strategy based in a systematic change of element, or outage that are prepared time by time. For example, one per year, or once every a couple of years, or something like this. But this systematic strategy is followed, for example, in automotive sector, or in some industry, like the chemical industry, or in power industry. In power plants, the majority of the power plants follow this systematic strategy. And only a few installations follow condition-based maintenance. But if you see that the result of this condition-based maintenance, you can see that the result in terms of cost, or in terms of availability, is very good. They spend less money, and they obtain a good availability. Which industry follow very well this condition-based maintenance strategy? For example, the aeolic industry, or the PV plant, the photovoltaic power plant. They follow perfectly this condition-based maintenance. They don't organize outage. They don't only activities repair what is broken. No. They analyze, they diagnostic the machine previously, the different machine that compose the installation previously, and according with the result, they decide to do something or nothing at all, depend of the condition that present the machine. Then, if you are a maintenance responsible, you are in charge to select the strategy that is better for your installation. Maybe only repair, follow one corrective strategy, maybe follow a systematic strategy, organize one outage time by time to do a lot of repair and a lot of substitution of element, or some systematic activities, or decide to follow one conditional-based strategy. According with that strategy, you must diagnostic. You must think a lot, because you need to diagnostic previously your installation. It's your decision, compare the result and decide.